Today we're going to deal with ratios and proportions. And what you know from middle school is a ratio is a comparison of two numbers, typically by division. Most people also think of a ratio as a fraction. So there's a lot of ways we've seen these written before. One way is something like 5 to 6 in words, or this 5 with a colon and 6, and the way you relate that to a fraction is the first number is the numerator, the second number is the denominator. If you've got two equal ratios or two equal fractions, we call that a proportion. So something like 2/5 and 12/30, those are equal fractions. How do you tell if you have two equal ratios? Well, you could reduce these. If you can't think of the reducing part, notice the highlights here. There are some special names for these numbers. The numbers in yellow are called the extremes, and the numbers in, I believe that's purple, are means. And there's a little expression, the product of the means equals the product of the extremes. Nobody ever remembers that, okay? But if you have equal ratios, then their cross products must be equal. So that's the one that most people stick to. So if I want to test if these two are equal, I take their cross products. And remember, product means we're going to take and multiply the cross. So I have 26 times 789, and that's supposed to equal 43 times 421. If these two quantities are equal, then I know that I have equal ratios. So 26 times 789 is going to be 20,514. And then we have 43 times 421, which is 18,103. So we can say these are not equal, therefore not equal ratios. The big thing though we learned is that the cross products have got to be equal if you have a proportion. So now I'm asked to solve these proportions, and once again, if they are proportions, then my cross product has to be equal. So I know that in this case, 2 times x will equal 3 times the quantity of x minus 3. 2 times x is 2x. I'm going to distribute this 3 through, giving me a 3x minus 9. Let's see, what do I want to do first? I think I'll add a negative 2x to both sides, because I like keeping my x's positive. 2x minus 2x is 0, and I have x minus 9 is equal to 0. So I'm going to add 9 to both sides, and x will equal 9. And just to check, I have 2/3 is equal to 9 minus 3 over 9, which is 6 over 9, and that reduces to 2/3. So I'm good to go. Let's do the same thing on the other side. I have two equal fractions, so their cross product must be equal. So in this case, if I take my cross product, I have 6 times the quantity of 9 minus 2x is equal to 5 times the quantity of 4x plus 7. Distribute each through. 54 plus negative 12x is equal to, distribute through, 20x plus 35. I like getting all my x's to one side first, so I'll add 12x to both sides. This gives me 32x plus 35 is equal to 54. I'm going to add a negative 35 to both sides. And then if I have 54 plus negative 35, I end up with positive 19. It's equal to 32x. I'll take and divide both sides by 32, and I get an x value of 19/30 seconds. All right, now a ratio where you have two different units is called a rate. So this is a rate right here, feet per second. You've heard meters or miles per hour actually, like we have over here. We have dollars per pound. We've seen things like that. And if a rate compares a quantity of a certain item to only one item of another, it's called a unit rate. So if I say 50 miles per hour, that means 50 miles in 1 unit of hour. So that's called a unit rate, if you will. So here's an example of a proportion. Joey Chestnut's going to hold the world record for eating hot dogs at 69 over a 10-minute period. If he could hold his food down long enough, how many could he eat in 3 hours? Well, in this case, we're going to set up a proportion. We're going to say hot dogs over time, and say those two rates have to be equal. So I know if I have 69 hot dogs in 10 minutes, that would have to be equal to, we don't know how many hot dogs, so unknown, let's call that X hot dogs in a total of 3 hours. Now the problem is, if I put 3 hours right here, my units are off. I have hot dogs on top, and I have minutes and hours on the bottom. So I'm going to have to change this so everything is in the same unit. So let's do that over here. We have 69 hot dogs in 10 minutes. And I know in an hour there's 60 minutes, and I have 3 hours. So that's 180 minutes. Now we'll do our cross product. So I've got 10x is equaling 69 times 180. If I multiply 69 times 180, I end up with 12,420. And that's going to be equal to 10x. And if I divide both sides by 10, that would mean if he ate at that rate, he could eat 1,242 hot dogs. Totally impossible, but that's actually kind of disgusting how much stuff he's throwing in his mouth. Anyways, moving forward. So sometimes rates are used as scales, like scale models. They do this a lot on maps and such. Let's do a couple problems here. So oftentimes car manufacturers will use smaller models to simulate what their car is going to look like. Let's say Ferrari is going to build a 1/32nd model of their cars. If the model is 4.3 inches long, so 4.3 inches, and this is the model, and I know that that is equal to a 1/32nd scale. That means the smaller part is the model, and the 32nd is the actual. I want to know what the actual length of the car is. I don't know what that is, so I'll call it X. Alright, so we take and do our cross product. 1 times X is X. 32 times 4.3 is going to be roughly 137.6. And that's equal to X. So if I have 137 inches, we know this is inches. If I want to know how many feet that car is in length, I could take and divide that by 12. Doesn't ask me to, but I will for kicks. This will give me the number of feet. So the car is roughly 11.46 feet, which isn't very big, so it's a tiny guy. Next, we got a key on a map that states 1 inch is equal to 52 miles. So if you've ever seen a map, here's a map. There's always this little slide down here, and it says something like 1 inch equals 52 miles. So what that means is that's really a proportion. It's a rate almost, but it's comparing one unit to another. So if I know that 1 inch is equal to 52 miles, then that's going to be proportional to every measurement on that map. So it says if Concord and LA are 320 miles apart, right, then how many inches are they apart on the map? So notice, my miles are down here. My miles must compare to the miles in the problem. I don't know how many inches there are apart, but I have inches to inches, miles to miles. So again, I'm going to take and multiply crosswise and get 372 is equal to 52x. Divide both sides by 52. And take 372, divide that by 52, we get a total of 7.15 inches. So on that map, they'll be about that far apart.